Millions of Black Americans have grown up carrying this story, a claim of Native American ancestry woven so deeply into family identity that it felt as certain as a surname. And then one by one, scientists began testing it. They collected DNA from tens of thousands of Black Americans and compared it to the genomes of every major Native American tribal population that had ever been sequenced. The Cherokee, the Choctaw, the Sioux, the Navajo, the Comanche, the Seminole, the Colville, the Chickasaw, and dozens more, tribe by tribe, chromosome by chromosome. What the results showed was not what most people expected. Let's start with the science, because before any comparison could happen, researchers first had to understand what Native American DNA actually looks like and where it came from. The story of Native American genetics begins not in the Americas at all. It begins in Siberia, approximately 25,000 years ago, in the region of the Altai-Sayan Mountains and the lower Amur River Basin, a vast frigid landscape spanning parts of modern Russia, Mongolia, and northeastern China. The people who would become the first Americans were not yet Americans. They were a population shaped by tens of thousands of years of Siberian and East Asian ancestry, carrying mitochondrial haplogroups that geneticists now label A, B, C, D, and X, the 5 founding maternal lineages that account for virtually all Native American mitochondrial DNA diversity across the entire Western Hemisphere. On the paternal side, the dominant Y chromosome haplogroup is Q, specifically QM3, a lineage found almost exclusively in indigenous peoples of the Americas and their direct Siberian ancestors. These lineages are as distinct from sub-Saharan African haplogroups as it is possible to be within the human species. Around 16,000 years ago, a founding population, estimated at fewer than 5,000 individuals, crossed from northeastern Siberia into what is now Alaska via the Bering Land Bridge, a massive stretch of exposed land connecting Asia and North America during the last ice age, when sea levels were roughly 400 feet lower than they are today. This was not a single dramatic crossing. Genetic evidence suggests the founding population paused in Beringia, the land that is now submerged beneath the Bering Sea, for thousands of years before the ice sheets retreated enough to allow migration south. Scientists call this the Beringian standstill. During those thousands of years of isolation on a frozen subcontinent, the founding population diverged genetically from both their Siberian ancestors and from all other human populations on Earth. By the time they moved south into the Americas, they were already genetically unique, a population unlike any other on the planet, carrying haplogroups forged in isolation that would never again be found outside the Western Hemisphere. From the initial entry into Alaska, they spread south and east across 2 continents over thousands of years, diversifying into hundreds of distinct tribal nations, languages, and cultures, from the Inuit of the Arctic to the Maya of Mesoamerica to the Mapuche of Patagonia. In 2014, geneticist Eske Willerslev of the University of Copenhagen published the first complete ancient Native American genome, sequenced from the remains of a 12,700-year-old infant boy discovered in Anzick, Montana, buried alongside Clovis stone tools and covered in red ochre, the oldest known intentional burial in North America. The Anzick child's genome confirmed the Siberian Beringian origin of Native Americans definitively, and proved he was directly ancestral to most modern Native American groups across both North and South America. A year later, Willerslev's team sequenced the genome of Kennewick Man, a 9,000-year-old skeleton from Washington State that had been the subject of a decade-long legal battle between scientists and 5 Native American tribes, and found the same result: unambiguously Native American ancestry closely related to the modern Colville tribe of the Pacific Northwest. The ancient genome of the Americas had spoken, and what it said was consistent. Native American ancestry traces back through Beringia to Siberia and ancient East Asia, and it has been genetically continuous on this continent for at least 15,000 years. Now here's what happens when you take that genetic profile, the haplogroups, A, B, C, D, and X on the maternal side, and QM3 on the paternal side, and compare them to the DNA of Black Americans. The honest answer is that the overlap is far smaller than almost anyone expected, and the story of why it is small and where it does appear turns out to be one of the most specific, geographically precise records of American racial history ever written in human DNA. A landmark study published in the American Journal of Human Genetics analyzing the genomes of over 5,000 Black Americans using data from 23andMe, one of the largest consumer genetic databases in the world, found that the average Black American genome is approximately 73.2% African, 24% European, and just 0.8% Native American, less than 1%. The researchers, led by Katarzyna Bright, compared these figures across every state in the continental United States. What they found when they mapped that 0.8% Native American ancestry geographically was something that looked less like a genetic statistic and more like a history lesson written in DNA. The distribution was not random, it was not uniform. It was concentrated in specific states and specific regions, in a pattern that matched the actual documented history of contact between Black Americans and Native Americans with stunning precision. The Cherokee great-grandmother story is one of the most widely shared pieces of American family mythology. Almost every Black American family seems to have one. So when geneticist Rick Kittles of Ohio State University traveled to Norman, Oklahoma, the heart of the territory where enslaved Black people and Native Americans lived in the closest documented contact in American history, he expected the genome to confirm it. He swabbed the cheeks of approximately 100 descendants of the freedmen of the 5 civilized tribes, Black people whose ancestors had been enslaved by the Cherokee, Chickasaw, Choctaw, Creek, and Seminole nations, who were forced to relocate to Oklahoma on the Trail of Tears in the 1830s and who brought their enslaved Black laborers with them. These were the people with the most historically documented reason to carry Native American DNA. Kittles hypothesized they would show approximately 20% Native American ancestry. The genome came back at 6%. As Kittles himself said, it was shocking. The history of proximity was real, and the genetic signal was real, but it was far smaller than the family story suggested. This finding, replicated across larger and larger data sets, has been confirmed repeatedly. The nationwide study in the American Journal of Human Genetics found that in Oklahoma, where African Americans had the highest documented historical contact with Native American populations, more than 14% of Black Americans carried at least 2% Native American ancestry. In states like Georgia, Virginia, and the Carolinas, where contact was less sustained, the figure dropped to between 1 and 4%. In states like Minnesota and Michigan, where the historical contact between Black Americans and Native Americans was minimal, the signal approached zero. The genome was not telling a generic story. It was telling a state-by-state, county-by-county account of American history etched into chromosomes across generations. If you are watching this and wondering why the number is so much smaller than the family story, stay with us, because the science explains exactly what happened, and it is more interesting than either the myth or the dismissal. Subscribe right now so you do not miss the part that changes everything. There are 3 reasons the Native American ancestry in Black American genomes is smaller than family tradition suggests, and each one reveals something important about how race, history, and genetics interact in America. The first reason is what geneticists call genealogical versus genetic ancestry. Every person has more genealogical ancestors on the family tree, than genetic ancestors. The further back you go, the more this gap widens. Think of it like this. You have 2 parents, 4 grandparents, 8 great-grandparents, but your genome is not divided into 8 equal pieces. Chromosomes are shuffled randomly at every generation, meaning some ancestral lines contribute DNA and others contribute nothing, even though those ancestors are just as real on the family tree. By the 5th or 6th generation back, the randomness is so significant that a real ancestor may leave no genetic trace whatsoever. Your great-great-grandmother is on your family tree, but statistically there is roughly a 1 in 4 chance that you inherited 0 detectable DNA from her. Her genetic contribution to your genome may have been lost entirely through the random reshuffling of chromosomes that happens at conception. A Cherokee ancestor from 6 or 7 generations ago, around the time of the Trail of Tears, has roughly a 1 in 64 chance of leaving any detectable genetic trace in a modern descendant. The family story can be completely true, while the DNA test shows nothing. These are not contradictory facts. They are 2 different ways of measuring ancestry, one by family memory, one by chromosome, and they do not always agree. The family is not lying. The genome is not wrong. They are measuring different things. The second reason is that family stories often traveled ahead of the facts. After Reconstruction, when Black Americans faced the brutal violence and legal dispossession of the Jim Crow era, claiming Native American ancestry provided a socially useful buffer in some communities, a way to assert dignity and a sense of belonging that American society was actively trying to destroy. In places where Native American heritage carried cultural prestige or legal land rights, the story grew in the telling. This is not a criticism. It is a completely rational response to a society that dehumanized Black identity at every turn. The genome does not know why a story was told. It only measures what genes were actually transmitted. The third reason is perhaps the most historically significant. Much of what Black Americans identified as Native American ancestry was actually something else, something the genome detected but did not label the way the family expected. A significant portion of the ancestry that registers as vaguely non-African, non-European in Black American genomes traces not to North American tribal populations, but to populations from Central America, South America, and the Caribbean. Populations that carry the same Mesoamerican and indigenous haplogroups as Mexican, Colombian, and Puerto Rican populations. This ancestry entered Black American genomes not through contact with Cherokee or Sioux in North America, but through contact with populations from the Caribbean and the Gulf Coast, whose indigenous ancestry was already mixed with African and European ancestry before those contacts even occurred. The genome preserved the signal, but it came from a more complicated source than a single Cherokee grandmother. Now here is where the story delivers its most unexpected twist, and where the comparison between Black American DNA and Native American DNA reveals something that neither population's history had anticipated. When scientists at the University of Michigan and Harvard ran a nationwide admixture analysis using 15,620 individuals from the Health and Retirement Study, the largest population genetic study of the continental United States ever conducted using genome-wide data, they found something in the distribution of Native American ancestry that defied every expectation. The population with the highest proportion of individuals carrying significant Native American ancestry was not European Americans, who had been intermarrying with Native populations across the frontier for centuries. It was Black Americans in specific regions of the South and the Great Plains, populations that had shared geographic space with Native American tribes not by settler expansion, but by parallel dispossession. What the genome was recording was the history of 2 populations who had both been displaced, both been enslaved, both been forced onto the same territories by the same colonial power, and both been denied the legal protections that would have kept their lineages documented in official records. The Cherokee freedmen, the Seminole Maroons, the Black Seminoles of Florida, whose ancestors were runaway enslaved people absorbed into Seminole communities so completely that the tribe fought multiple wars with the United States partly to protect them. The 5 civilized tribes' Black enslaved populations who walked the Trail of Tears alongside their indigenous enslavers. These were not stories of casual contact. These were stories of shared suffering, shared displacement, and in many cases, shared community. And the genome recorded all of it quietly in the fractions of a percent that show up when you map Native American ancestry and Black Americans by state, by county, by the exact geography of American racial history. The Seminole case is particularly striking. The Black Seminoles, known in Florida as Estalusti, meaning black people in Muskogee, were the descendants of enslaved Africans who escaped to Florida beginning in the late 17th century and were taken in by the Seminole Nation. They lived in separate but allied towns, spoke Muskogee and Miccosukee alongside their African languages, and over generations formed one of the most remarkable communities in American history, a people who were simultaneously African, Native American, and American in ways that no single census category or legal definition could capture. They fought alongside Seminole warriors in all three Seminole Wars against the United States Army, with military engagements recorded as recently as 1858. Their descendants were scattered across Florida, Oklahoma, Texas, and eventually Mexico, where some communities persist to this day. When their DNA is tested, the results show exactly what the history predicts: elevated Native American ancestry compared to Black Americans in states with no documented Seminole contact, with specific haplogroups matching Florida and southeastern tribal populations. These haplogroups, the mitochondrial A2 and C1 lineages associated with southeastern indigenous populations, appear in Black Seminole descendants at rates 3 to 4 times higher than the national Black American average. The genome and the history tell the same story. They always do, when you look closely enough. So what does all of this mean? The 0.8% average, the 14% Oklahoma peak, the family stories, the Black Seminoles, the freedmen DNA tests, and the 12,700-year-old child in Montana whose genome connects every Native American tribe to a single founding migration from Siberia. It means that the comparison between Black American DNA and Native American DNA is not a story of no connection. It is a story of a very specific connection, a connection forged not by ancient continental migrations, but by American history itself. It is written in the elevated Native American ancestry of Black Oklahomans, whose great-great-grandparents walked the Trail of Tears in chains alongside the people who enslaved them. It is written in the Florida Panhandle communities where Black Seminole descendants still exist. It is written in the 6% average that Rick Kittles found in Norman, Oklahoma, far less than the family stories predicted, but unmistakably present and unmistakably tied to a place and a period in time that the data can name. The Cherokee great-grandmother story is not a lie. In many cases, it is a compressed and simplified transmission of a real historical truth that Black Americans and Native Americans shared space, shared struggle, and sometimes shared bloodlines in the specific territories where American history forced them together. The genome confirms the connection. It locates it more precisely than the family story did. But here is the deepest finding, the one that neither the DNA tests nor the family stories had prepared anyone for. When researchers compared the ancestral haplogroups of Black Americans to the founding haplogroups of Native Americans, the A, B, C, D, K, and Q lineages that trace back to Beringia and ultimately to the Altai-Sayan mountains of Siberia, they found a genetic distance even larger than the one between Black Americans and ancient Israelites. This is because Native American ancestry is itself a subset of East Asian ancestry that diverged from the African root of all humanity approximately 50,000 to 60,000 years ago. The two populations, West and Central African on one side and Siberian Beringian on the other, represent two of the most genetically distant populations on Earth. Not because either is lesser, not because either is isolated, but because one lineage represents a population that stayed in Africa and was shaped by 300,000 years of the oldest human environment on Earth, and the other represents a population that crossed a frozen land bridge into an uninhabited hemisphere and spent 15,000 years in almost complete isolation from the rest of the human species. When those two populations met in colonial America, one was brought in chains and the other was already dispossessed of the land they had inhabited for millennia. What followed was not just history, it was genetics. And the genome holds both stories simultaneously, in fractions of a percent, mapped by state, by county, by the exact geography of where two peoples who had nothing to gain from each other's suffering were nonetheless forced to share it. That is what the data shows. The genome is not sentimental. It does not round up. It does not honor family mythology. But when you read it carefully, when you map it by state, by county, by the historical geography of contact between two dispossessed peoples, it tells a story that is more honest, more specific, and more American than any version of it that has ever been passed down at a dinner table. And for the first time in American history, the science can read it.